Welcome back to Brothers Code. I'm Carl, and on the other end of this call is my brother Eric. We're
That's me.
That's you. We're going to be working on the heat shader that we've been tinkering with a little bit this morning. So since this is a continuation, we're just going to kick right back into it. Let's see. Oh, that's the wrong display. There we go. This is your code. All right. So over the break, you added added the north-south direction, right?
Yep.
Cool.
So in Unity, if we fire it up, we're able to have what kind of looks like a normal element. If we plop some heat in there,
Sweet.
it looks to expand. When it stops expanding at the edge, here it's just kind of staying because it doesn't know what to do. Same thing with heat in the middle of space,
Mm-hmm. Just
doesn't
doesn't
know
do
what to
anything.
do.
Do you want heat in the middle of space to evaporate? Is that, I guess ideally there should be no heat in the middle of space, right?
Yes, there's nothing for it to be heated up, heat of. I don't know. There's nothing there, therefore nothing
Yeah,
can be hot.
right.
Yeah, so next step is to make it flow with the unit that is flowing.
So this one's going to be a little trickier, right? Because it's going
Oh yeah.
to, we have to still have to conserve heat, otherwise bad things happen.
Hmm.
But we want it to actually travel with the flow as well. So you did something to
Yes.
already get the flow in each direction as a property, right?
Yes. So this is the flow code,
Hmm.
and here at the bottom we keep track of the northern flow in the green channel. So of our box, we have the northern flow, and in the blue channel we have the eastern flow. The reason only north and east is because if we take this box as green, which is north, that is the negative of this one's south.
Cool.
Same thing goes for this one,
That one's blue is the negative of that of the center one's right, east. Or sorry, center one's west.
west.
Yep.
Yep,
Cool. Okay. So this one, I feel like we're gonna have to probably do some more theory for this, right?
probably.
Because now, so we have the static case pretty much solved,
Uh-huh.
where if two things are not moving and they're next to each other, then the heat will flow from the hotter one to the colder one.
Yes.
However, now I think that there's at least two different situations that we're going to need to figure out. We have the case where there is, so in this case where one thing is hotter than another, which we can just generalize to always be the case,
Mhm.
then there's like material is greater in this, like it flows this way, or material flows this way.
Yes.
And wacky stuff can happen in both of these cases, right? Because the actual temperature transfer is going to depend on how much flows and also how much heat flows with it when you do this.
Hmm.
So, do we know at this point what the final amount of stuff is in each cell?
We can. So if this is run
Hmm.
before the final height update,
Hmm.
then height contains the previous value's total amount. And if we run it after the height update, then it's equal to the sum of the amounts.
Okay. So how would what have you thought about this so far? Like catch me up
So
a
I
little
thought
bit.
of doing this in two steps.
Okay.
The first one being, okay, we have stuff that just flowed,
Hmm.
take the heat with it,
Hmm.
and then calculate the new height map
Hmm.
and now spread the heat.
That sounds right to me. So you're gonna duplicate the shader, basically?
Um, yes and no, because the actual calculation of that height map is not required to run the shader
Okay.
because we know exactly what its output will be.
Oh, right, because we have the flow amounts.
Yes.
Okay. Wait, but you don't have the flow amounts for your adjacent cell. You have the flow amounts for your cell, but not your adjacent one, right?
Ah, but you do, because every adjacent cell stores its northern and eastern flow, and you can calculate.
What I'm saying is you don't know the ending height of your, but like, so the cell to the east, you don't know
Hmm.
the ending height yet, because because the ending height here depends on this cell down here, which you don't
Uh,
have a reference to this one.
you do know it because it has already happened.
Oh, so you're going to do this update after the height texture is updated.
Either so the main script, it's just easier to look at there. Here we have screen. This this updates the elements,
Mm-hmm.
and then we can either write the height map and then write the shader, or for the heat, or if
Mm-hmm.
heat is here as before, then the height texture contains the previous amounts, while summing up the flows gives you the final amount. Because all this does is
Right.
sum up these.
Okay, so it should probably be in the other way then, right? Is that all
Sorry, in
right?
this direction or the other one?
The other direction.
So now height is just purely the sum of the uh, the flowed elements.
Yes. Oh, I see what you're saying. Okay, right.
Because so for to be able to know what percentage. So when I was doing the heat version of this, I
Mm-hmm.
took a percentage of the uh, material that was there
Mm-hmm.
times what flowed times the heat capacitance and took that much heat out of the flowing box.
Mm-hmm.
Now I'm not sure how that's gonna work with temperature.
Well,
Um,
I feel like we need to use conductance kind of the same way, where you can say, well, conductance is for oh yeah, you're right. Maybe we need conductance and capacitance.
well, because so we have
So
one
like
box on the
flowing.
left
Hmm.
and one box on the right, and if material flows from the left to the left is still the same temperature. Like the no temperature didn't flow out of it.
Right.
Heat flowed out of it.
Yeah, heat flowed out of it, temperature did not. So, while temperature spreading is then based on delta T, is based on change in temperature. But
Yes.
flow is based on heat, which means that flow is based on heat capacitance, not conductivity,
Yes.
right? Because imagine the situation comparing flowing copper, right?
Yeah.
Like you can have copper that is hot and
Yeah.
flow in a direction,
Uh-huh.
and it would bring the heat with it.
Uh-huh.
But even if it's flowing in a direction and it's hot, if the direction it's flowing is cold, temperature could propagate back up the flow faster than it flows forward.
Yes.
So you could freeze the copper by flowing into something cold, even if the copper is hot.
Yes.
Well, this is going to be wacky, but so it is capacitance that we need to flow, which means that do we need another? Well, you can calculate the total. So you can calculate the total heat capacity just like we did for conductivity, right?
Yeah.
Because you have all the data you need.
Yeah.
Do you have an idea of how
So
to get started
that's
on this?
uh, that's the hardest part, right?
Yeah. So,
Um, so we're gonna get some transfers.
mhm. Oh, because the weird
Uh,
thing is basically you're going to have to do an instantaneous conductivity check in order to update the temperature of a cell after things flow, right? Because let's say something super hot and something super cold flows into the exact same cell, it still needs to have one temperature.
hmm.
So then that's going to be proportional to the temperature is going to be like you're going to flow the heat and then you're going to compute the temperature. And then you're going to use the temperature to compute the conductivity temperature flow. Does that sound right?
There were a lot of words in there.
So so the first like I think you're right about doing this in two steps is what I'm saying. The first step
Okay.
you do is you calculate so check me on this.
Hmm.
The first step that you do is you calculate everything's current heat that it has in the cell based on the temperature and the
So,
heat capacity of every element.
okay, so you back calculate the heat from the temperature.
Right. And then you say I'm flowing things around and I'm taking heat from this cell and moving it into various places,
Okay.
right? Moving it into adjacent cells.
Yep.
Uh, then after everything flows, then you find in each cell how much temperature, or sorry, how much heat came from various places. And how does this work? And then because then you have to forward calculate the temperature of that cell because it can only have one temperature.
Yes.
Right. So, but this is okay. So, but this this doesn't quite make sense. So help me figure out where this is going wrong. Because if you flow heat out of a cell, the cell doesn't
Hmm.
get colder. Like we just talked about this.
If you flow material and heat out of a cell, it does not get cold.
Right. Yes. So sorry. If you flow material and oh right. Okay. So that's why because you're flowing the material too. So that works. So then you flow it into the next cell, and then you do as I supposed, right?
Yes. Is it still beneficial to us to work in terms of temperature then? Because the flowing of the elements would then be you flow the heat, you work with heat, and then at the end you calculate all the temperatures.
Yeah. I mean, we could do it that way for sure. I think it's whichever you prefer because there you can calculate, like you pointed out, you can calculate one from the other.
Hmm. The only problem is that I was running into a whole bunch of divide by zeros.
Oh,
But
when you what when you were using heat?
when I worked in heat, I ran into a bunch of divide by zeros. And it might have been similar mistakes to that. It was just really hard to debug.
Hmm. Well, let's work in temperature then and just compute heat.
Okay, let's try that.
So yeah. So this stuff has got to go before the flowing of or the before the conductivity checks, right?
Hmm.
Because is it well, I guess actually you can do it in either order.
Yeah, so
It just depends
this
on.
is independent,
Hmm.
and but this heat
Do you want to just comment all this out and do heat movement as a
kind of
okay.
so that we need, those we don't.
Back to square one.
Back
Hey,
to
look,
square one.
we
Heat
did it.
movement. Problem solved.
We're back where we started.
This is all caps.
Hmm. Like any good
Um,
forum post.
right. Sure.
Yeah,
Yep. Just yep. That seems
neat.
good to me. I don't know. Random values, pretty much. Maybe we need small. I'll forget to. That's duplicated later, and it'll come back to bite me. But that's
Yeah, it'll just complain at you. Okay, so you have your heat capacities.
yeah.
So now you need to we take temperature and convert it into heat.
So this that's the temperature.
Hmm.
So heat is this temperature in the current cell divided by the amount which it is not,
Which is not the height.
which is not the height, the amount in this cell.
Okay,
Nope, multiplied by the amount in this cell. So this could be
right.
0.
Wait, but it's also multiplied by the capacity of each individual value, right?
The amount of that times. So this is a weighted times the
It's a
average.
weighted sum. Wait, I don't think you don't need to average it, right? It's not because it's not an average, it's an actual sum. Because however much water there is at that temperature, all of them only increase the amount of heat,
Uh,
right? Because heat is a summation of those.
so if we do water times the capacity of water,
Yeah.
oh yeah, because it would just be the average times the total amount, and the total amount is what we're averaging it by.
Right. Yeah.
So those cancel out. Math is good. Everyone's happy. Hooray!
Yay, look at that.
Lovely. Lovely, lovely, and lovely. So the heat is this pixel's temperature
Hmm.
multiplied by the amount times their capacity. So assume it's all water.
Yeah.
It's water divided by water times the total amount, which is just water, which ends up with this,
Yep.
times that capacity, times this temperature will give us heat. Does that make sense?
Makes sense to me. I
Hmm.
don't know what the scale is of capacity. I think that's one piece.
Uh,
I mean, 0 to 1 is safe, but
I mean, 0 to 1 is what they're going to have to be,
really?
but, well, because everything has to be passed as, or no, they don't have to be,
I mean, in
because
this
they
case, they
still have
don't.
to be part of the textures.
Yeah.
So the heat
Because when
capacity
you,
of water is like that or something. Uh,
yeah,
like
it's really crazy
joules
high.
per, yeah, it's like
Yeah.
the amount of joules it takes to
It's
heat up 1 kilogram by 1 degree.
right. Yeah, just an absurd number.
So just massive.
So let's get, I guess, so these, I think might only be the relative values that matter,
Yes, it
but
should be.
so I guess we can leave them in 0 to 1 range just to be safe, but I think that they should cancel out later. My intuition, you probably share this too, the intuition is that these values should cancel out after you do the flow, because
I
we
would
need
hope
to
so.
resolve everything back down to heat anyway. Or sorry, we need to resolve
To
everything back down
temperature.
to temperature. Yeah.
Yeah.
Okay. So this is the current heat,
Hmm.
and you're going to flow some amount out of it.
We can do good copy pasta again.
Yep.
East,
You're gonna just do the east-west thing again.
east, yeah, east, east, and
That is really
this.
clever, by the way.
Thanks. West. So yeah, this east and west.
Hmm.
What are we doing with them?
Well,
The heat needs to flow,
heat needs to flow, and
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 this pixel needs to flow.
unlike temperature, all the heat can flow out of this cell. So
Yes.
the intuition is that it's just dependent on the flow. It's not dependent on anything relative between the two.
Yes.
So,
So we know how much flowed
mhm,
of each element using the tricks that we had before with the northern flow, the eastern flow, all that kind of stuff.
so those are right. So we should probably pull those out into variables just to make this
Yep.
easier to reason about. At least I would
So
like that.
eastern. It's good because we have flow east as well. So eastern flow is all of these,
Say what?
but the green component. That is
That's the
how
Eastern
much.
total material flow.
Yes, eastern total material flow.
Right, but we want the Eastern total heat flow.
We don't know that yet. That's what we're
Well,
calculating.
right, but we can though, right? Because you just multiply each one by the capacity,
Hmm. But
right?
there's no flow here.
Hold on. Let me think about this. So there, but that's the whole. No, Wait,
So the heat flow we did
wait
here.
for it.
This is heat flow.
Okay, yeah. So no, this is temperature flow.
Or sorry, temperature flow. Yes.
This is temperature flow. So we're doing heat flow. So the amount of material that flows times the capacity times the temperature is the heat flow, right?
The amount of material that flows.
So you
For
have to still
example,
do
how
this on
much
a per
water?
component basis.
Yeah, how much water flowed to the east
Hmm.
times how much heat capacity water has
Right? Times the heat in the, oh, wait, hold on, times the temperature of the place that the water came from.
times the temperature of the place that the water came from, which is this pixel.
Right?
Temperature
Yeah. Is that right?
is
That's the,
what?
so this is, I mean, this is the heat flow of water,
Heat flow east
of water.
water.
Yeah.
There's gonna be a lot of variables here, but
Yeah. I mean, well, but you can sum them all because you can flow all of them at the same time, right?
yeah.
Because you're just calculating heat, so you can actually do this like total heat flow, like or heat flow east
Okay.
as the
And
sum of all of those, right?
how does this help us?
Well, so what, I mean, you're going to increase the heat. Wait, hold on, you can only edit your own cell. So you're going to decrease your own heat by that amount.
Yes. Okay, this is starting to make sense to me. So we know the amount of heat that flowed, therefore we can calculate how much we should have, our delta heat.
Hmm.
Take that by the new amount of whatever we have in our cell
Hmm.
and add that to our temperature. That is
Right.
the goal.
Yes, that is the goal. Because you're going to have heat flow, you're going to have heat flow into the cell from, right,
And out.
everything's flowing in. Right, but
Everything's flowing in?
well, from the perspective of this, everything's flowing in.
Okay.
Like, or you're only gonna update your own temperature, right? So you're gonna have heat flow in from four places, or in this case, I guess two places. You're gonna have heat flow in from two places, and then you're going to take the resulting amount of heat and the amount of material that you have, and then use that to compute a temperature.
Okay.
Physics, yeah.
Physics. In this pixel R, maybe everyone. We don't.
I think it's everybody. You can factor that out.
These are adding.
Yeah.
Yes.
I'm very satisfied by you lining these things up.
Thanks. So we have water steamometer times our capacitance, and this is the flow to the east is stored in green, multiplied by this temperature.
Right.
So this is all out flow.
This is heat out. Right.
Heat flow out east. Water. It's total.
Hmm.
Calculate the flows outward in each direction. So in west is the same, but it needs to be the out west, which is the negative of this pixel's west component.
Wait, no,
So
that's still
let's just do it positive first.
right.
And let's see if it works. So this pixel's west component.
It's still multiplied
by water and lava and dirt and everything. West, green, which means eastern.
I think it's this pixel, it's not this pixel west, because that's the temperature of this cell, which you're still flowing out of this cell. Right? It's just that the pixel that you're getting this data from changed from here to the west component's G member. Right? Because you don't want the temperature of the pixel to the west, you want the temperature of yourself. Because in the material flow,
so
water W is material flow from the pixel to your wests going in the direction of east.
So because this could be negative.
Right. So then you negative the whole thing. because you want to reverse the direction of the flow.
Then I'm not sure this works.
Well, because that's temperature.
Yeah, and the temperature here could be temperature, because remember, these have to equal.
Yeah, yeah. Wait, hold on. What has to equal?
So when I am the western cell, my eastern
Oh, you're right.
calculation has to equal the eastern cell's western calculation.
Wait, no, you don't. No, they don't.
Well, otherwise heat just is created or destroyed.
Hold on. Hold on.
What I take from the west has to go to the east, right?
Yes, but also, okay, so now I'm this is another point of like of weirdness. So, yes, and also you can have a flow between two cells that is not symmetric. You see what I'm saying? Like if I flow like so consider a situation where I have uh, water in my cell and uh, steam in the other cell.
Okay.
So we're and if we're let's say we're at the same how do I say this? Let's just say we're at the same temperature, doesn't matter. So this isn't
Yep.
going to affect temperature, but it will affect the heat calculation, which
Yes.
if we flip places, like let's say 100% of the water in my cell goes to their cell
Well, that's the
and
thing.
and they just
You
flip,
you can't.
why not?
Flow only occurs in one direction.
What?
So
Wait,
flow
all
is based on
flows?
height. All flows
All
are based
flows
on the
only
height.
occur in one direction.
Yes.
So if you flow, okay, this is making more sense. So if you flow, so a cell flowing in a direction flows all materials at the same rate?
Yep. Yep. Because this is based on height.
Okay.
So this is just
Huh.
so everything will flow in the same direction,
Yeah.
but will flow proportional to how much they have of
Hmm.
whatever it is, and how much
How much the
material they
target
can
has?
give.
Okay.
Yeah,
All
but all
right.
the flows occur in the same direction.
Got it. Okay. So that helps. So that means that so flowing to the if you're flowing to the east and we
Hmm.
say that you're taking some temperature with you based on the capacity of each of the materials that is flowing,
Yes.
then that amount needs to be balanced on the target cell by a similar calculation.
So let's assume that our cell
Hmm.
only contains water,
Right.
and there is a cell to the east that contains nothing.
Okay. Yeah.
Um, and half of the water flows to the cell to the east. So that means this temperature, whatever it is, so the temperature should always be the same
Hmm.
because nothing's happening other than the material moving place. So this temperature times the water amount that flowed times the capacity of water, we move to the eastern cell,
I think I know the problem.
and
I think I
then,
know the problem.
okay,
I think the temperature has to be the temperature of wherever the flow is coming from.
which
Does that sound right?
means
So
yes.
that means that it either has to be if it's flowing out of if it's positive and heat is flowing out of this
Hmm.
cell, then you use this temperature. Otherwise, you use the like if it's flowing into the cell, then you use the target temperature, or sorry, the source's temperature.
Which is this, but a little bit different. So,
We can write it with an if statement now and then just check to see if
well,
it
no,
works.
it's the max of those. So, but instead of in there, uh, crap. This this is heat flow east.
Hmm. that is always the amount of heat that's flowing. Well, I mean, it's the heat
This is
flow
the
multiplier.
material flow east.
Yeah, yeah, material. Yeah.
Capacitance,
Capacitance.
material flow,
Yeah,
whatever.
the sum of all the capacitances of the material that's flowing to the east.
Heat flow out. Okay. If we are flowing out to the east,
Hmm.
we want to multiply it by this pixel's temperature.
Yep.
And if we are flowing in from the east, then we want to multiply by the eastern temperature.
Right.
So if we are flowing out, this is positive.
Yep. And then we
And
use
if
this
we're
one, which is
flowing
also
in,
positive,
this is negative.
which doesn't that make the max
Wait, dang it.
0?
Yeah, yeah.
Oh, it's minus
Right,
the
right.
min. It should be minus the min,
Hmm?
right?
So what this is trying to do is emulate a switch statement.
Right. So I got that. So, but I think it's minus the min, not minus the max, because flow out east will be negative in the case that you're flowing in from the east, and the temperature is always positive. So in this case, you're going to get a negative number, and you want to
Which
select that one.
do we want to?
Yeah, because it's flowing in, then you need to pull the temperature in, or pull the heat in, right?
Uh, Eastern. So okay, hold on, one more time. Flow out east is positive.
Yeah.
We want to use this cell. Flows east is negative. We want to use the other cell.
Right.
But this is, yes, correct, min, because this is negative.
Hmm.
So assuming this is positive and it flows out, we do want to use this one.
Yep.
And because that is positive, because the temperature is never negative,
Right.
this one would
Good
also
call
be
on using
positive,
absolute temperature.
right? Okay, so that works to select
Yeah,
it.
that worked to select it. Yeah.
And then we had a nice comment saying,
It's like, this is what's going on here.
what is this statement do? Why
Yeah.
is there max and min? I don't understand.
Why is this thing so crazy?
Goes east, take this cell's temperature, assume flow incoming, whatever, outgoing, take other cell's temperature. Cool. So that's a thing. And then we
Nice.
copy paste that. Oh, did I already do that? I already did that. Hooray! Flow out west. Doesn't need that in it. And then heat flow out west is the same thing, but with a west. And west heat.
Looks right.
Cool.
Okay, so now that heat has been flowed, heat has been flowed.
Wait, is this true? Did we do this right? The western green is the
Mhm.
east.
Is
Eastern
the
flow.
east. Wait, it needs to be the
Eastern
negative of
west.
that though.
Yeah, the eastern flow of the western thing, so it's negative.
Nailed it.
Well, negative 1.0 times negative west negative west eastern flow is this western
This western flow.
flow. Yes. Okay.
There's some
like
there's some words in there.
That's like commenting, just like hack.
Yeah. Hack. It's like, oh, good, thanks. That's helpful.
The next good comment. Good comment.
Yeah.
Comment of the year award right there. So,
Okay.
that's correct. So that means this is correct.
Hmm. You need a semicolon there, bro.
I do? Yes, I do.
All right.
What do we want to
So
do with this? So we have outflow west and
Right.
out east, out east, out west.
now you want to mod your own heat, right? You want to subtract these values from your own heat and then calculate your new temperature.
So this pixel's heat.
No, it's pixel's temperature.
Sorry, this pixel's temperature is this pixel's temperature times.
Wait, say what?
Well, first you have to convert this pixel's temperature into heat.
Right, we did that already.
Add the heats. Wait, did we?
Yeah. Heat.
Oh yeah, we did. So is this
Saved you some
pixel's...
typing.
All right. This pixel's heat
Yeah.
plus some stuff, or minus some stuff because it's out.
Mhm.
Minus out east, minus out west. And
So that'll be the new heat. Now we need to convert that back into temperature.
You're not Gucci. Good at typing. So that heat temperature is
A good question. Wait,
heat divided by amount.
yeah. So maybe where you compute heat up top, you should split that out into computing heat capacity and heat.
This.
Yeah, because we just need that number again in order to get temperature.
This one,
That one.
which is the amount times capacity.
Wait,
This
I
heat
see a problem.
capacity.
We need
What?
we need heat, or we need the amounts before and after flow. Right?
Ooh.
Because you need the amount of heat before flow, and then you need the amount of capacity after flow. Right?
Do we?
Yeah, we do, because otherwise you're gonna end up. Is this right? Yeah. Yes. Yeah, because otherwise this calculation doesn't work. Say what?
What?
Okay, so the A channel is now what the heat used to be.
Yes. Well, no, the A channel is what the amount used to be.
Or sorry, what the amount used to be. Okay.
Yes.
And the R channel is what it is
What is
after
that?
flowing. Okay, cool.
Yes.
It's a good thing these shaders have 4 channels because we're using all of them.
All right. Okay, so what else do we need to do? We need to do keep track of the old amount of stuff in this cell.
Right.
And then the pixel amount is the pixel red amount as the sum of the flows.
Cool. So
Now, what do we need that for?
the old amount, well, so we need the old amount to know how much heat was there before. So the heat calculations up top should actually use the A channel, not the R channel.
The heat is this pixel's old amount.
No, this pixel's old temperature.
Which is this pixel, because
Which is
it's
this pixel.
changed.
This pixel R, right?
Yeah.
But then times water, so water.r. Wait.
Yeah, so
all of those need to be dot A. Because it's the amount of
old amount. Yeah.
the amount of water that was there before, steam, lava, dirt, whatever.
Yeah, because this isn't updated yet.
Right. But those are.
These are. So easiest way to do this is .r, .a, yep, and then fix this.
Cool.
So that's calculate the old heat of the cells.
Yep.
So this would be the old heat flows.
Well, it's, I mean, the
That's
heat that has flown.
It is heat that has flown, yeah.
Yeah. And then the thing that you need now is you need to take the old heat, adjust it by the amount that's flown, and then take the new heat capacity and divide it by the new heat capacity based on the amounts of stuff that's there now.
Yes, heat divided by amount.
Yeah.
Which we're not shortcutting as height, but maybe good.
Well, isn't it just
So
exactly that value from above? It's not the amount, it's actually the capacities. Right?
Yes. But not the old capacities, but the new capacities.
Right.
A is .r.
And now we have our new temperature, theoretically.
Temperature is heat divided by... Wait, what?
Yeah, capacities.
Capacities.
Okay,
Cool. What happens?
let's see. I'm excited to see what this does.
We don't
So
know.
if you lay down some heat, nothing should happen, right?
Heat should not move.
Yeah,
If I have some lava, which is blue,
nice blue lava.
but what?
Well, it doesn't have any heat, so
Every, everything. Yeah, but then if it doesn't have any heat, it should be white. What? What?
huh.
E-
Heat is infinite. Heat is infinite.
Damn it.
Actually,
Did
heat
something
is
wrong.
infinite because the capacity of every cell is zero, or of many cells is zero. And so I bet
Are
it's
we divided
flowing
by it?
zeros. Yes, there's a divided by. So do the plus small.
Oh, where? I don't see the divided by. Oh, because
That one.
this is zeros, a bunch of zeros.
Yeah, that's a bunch of zeros.
Plus small. You know the divided bys we gotta look out for? Or is it
I
no?
don't think so. I think everything else is a multiply.
Okay. Hmm.
Bye.
I mean, something happened. Something
Yeah,
is
but it's
happening.
something is happening, but it's not. Well, I mean, okay, so those things aren't flowing anymore, so I mean, that's correct.
I
But
mean,
it should flow the heat with it.
something is wrong.
So let's check to make sure that that value is actually getting output. Like this
With
pixel.r
this
is
value.
getting returned. Yeah, is this pixel getting returned?
You know
Okay,
what?
all right.
Okay.
Just checking the easy stuff.
Yep.
Uh,
Hmm. So heat is zero
mhm. Because this thing has no temperature.
because nothing has any temperature in the beginning.
Right. Then the heat flow out.
Yeah, there's no divided by, so it should just be zero. Or, oh, hold on, is this becoming negative? No, because that's zeros.
Well, flow out. So this pixel is zero and the other pixel is zero. Everything's zero.
Everything should be zero.
Everything should be zero, which means that heat should be. Well, so okay, so here's a question then. Heat is computed with the old capacities and temperature, and the thing it's being divided by is the new capacities and temperature. Or I mean the same capacities, but it's the new total capacity.
Mm-hmm.
So in the case where something flows, the new capacity can be zero, whereas the old heat is non-zero, which means that, well, I mean, the old heat should be zero because there was never any heat in the first place.
Also true.
Yeah, what is happening here? Let's just remove the flow and see what happens. Like,
Hmm.
just set those
These
flows to
ones?
zero. Yeah.
Yep. So if those are zero,
Hmm.
and heat is zero, everything's zero.
Yeah.
As usual. Usual suspect. Hey, it's white,
Okay, so the problem is in the flow, as it always is.
right?
Okay,
Okay.
so what are
Equals
we
heat.
missing here?
Hmm. So if hold on, right now if I'm giving some heat to the element
Then you
times
give
some
it
stuff,
temperature times some stuff. Yeah.
and then I divide that stuff by the same thing,
Well, by
this
the
should
updated thing. It's not the same thing,
hmm,
right?
true. Well, so then I should be able to get these to go away
Well,
with
wait,
enough flow, right?
how is that?
So stuff is flowing here.
Yeah. Oh, but we just set the flow values to zero.
Oh, but heat isn't zero.
Yeah. Oh,
Like
wait.
heat is this pixel times some capacity
Mm-hmm.
of the old capacity. And then we take that same heat and divide it by the new.
But the new capacity, which is always less than the current capacity, right?
Is it
In the
always
case where you
less?
have,
No, it could be
well,
more
no, it
if
could be
there's
more. Oh yeah, you're right.
it's increasing.
Is the update order correct? Like, is the new capacity actually getting set, or old capacity actually getting set, like the dot A?
Dot A should be getting set before dot R, yeah.
Oh, I mean, okay. I meant this whole script, but of course it
The main
wouldn't work
script.
otherwise.
Yeah. Hmm.
Heat flow out east, heat flow out west.
Is this a texture that supports? Yes. They all do support ARGB. Heat as well.
Yeah, maybe stick out just the A values in the heat thing, and let's see what happens.
Uh,
Like,
just the A
just
values
the A
you mean
value for water or something.
here, like water.a.
Yeah, just make sure it's doing something. Debugging shaders is fun.
Right? So we have some water. Yeah, doing something.
Okay, so at least we know that. What about subtracting the two? Like, sorry, subtracting the water.r from water.a. I mean, I know in some
So
cases
this
this can
might be
produce a
negative.
negative. Yeah, so multiply by 0.5 and wait, hold on, multiply by what is it? Yeah, there you go, and then multiply by 0.5 because then it'll put in the range of 0 to 1.
Mhm. We hope.
Well, you got to multiply by 0.5 as well as add,
Yeah.
but yeah. I mean, I think we saw it working, but you're right.
Yeah.
Water
So
flows.
there is some difference.
Yeah, and it's darker where the water's flowing from and brighter where the water's flowing to. So that
Okay.
works. So
All
it's
right.
it's doing that correctly.
Hooray.
So let's see.
Mhm. Doot, 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 doot. So does it flow eastern?
Does heat flow eastern? Is that what
Oh,
you're?
right. No, I don't. I don't actually.
Wait, no, you're computing that.
Flow out east. Yes, I don't want. I don't want those. I just want to see if it can calculate the eastern flow. Uh, hmm.
Just at all?
Wait a minute.
No, this is
This because this is green, right?
mhm.
Oh,
It's giving you, yeah, you just need to
yeah.
take the,
Crap.
yep, second float there.
So if it flows to the east, this is hard because it flows north-south.
Yeah,
I'm not. Oh, there's some yellow. But
wait, but these values are all scaled really small. Let's set all the capacities to 1 just to see what happens.
true.
Okay, so it's definitely flowing.
Yeah, it's yellow on the edges.
Yeah.
as it should be. Because
Hmm.
any west or east flow.
Yeah, right. It'll be registered in there.
Yeah. Whereas this
Oh yeah, that should right.
is
If it's
pure east flow.
right. Say what?
Hmm.
That looks
I
like
mean, there's
southern flow. Do you see that?
yeah, yeah. Oh, maybe it's because I'm multiplying by 10. I don't know.
Oh, yeah. No, it still looks southern.
Well, lava would be southern. Yep, lava southern.
So it's
Did I
maybe the
mix up the
flows,
channels? Am
maybe
I
the
silly
channels
me
are
and
mixed
mix up
up.
the channels? Yeah, blue is east. Yep.
All right.
Yes.
Well, so
Yeah.
that helps a little bit, at least with that. But
Hmm.
does that? Oh yeah, there you go. Hey, that looks really cool, actually.
What is it doing though? Is that now western flow?
That is well, so it has color
Yeah,
in the
color
left-hand
on the
side.
west.
So color on the west means it's. What does that mean?
Let's take the green. The green. Uh, oh, because this is inflows.
So it needs to be. So we just need.
So,
Well, we can't make it negative because it still has to be in that range.
uh,
I mean, you can do one minus, or there you go.
wait,
Right.
I think that
Oh yeah,
works.
no, that yeah, you're right. That works. That works. That works.
I'm not sure if that works. Yeah, okay, that's eastern flow.
Okay, we got the eastern flow now. Okay, so let's go
This
back
is
to our
hard
sheet.
enough without all the cheat
I know.
standards. I need to go standardize. Do we use inflow or outflow? Like, come on. All right,
All right, so
we have east.
yeah, now we know we have eastern flow. So are you just gonna try running this with the heat?
Well, I assume western flow is now okay. Because why wouldn't it be, right?
Right. There's no
Uh,
possible reason that this could go wrong.
no, no possible reason. So this we want to put back in, and we just kind of hope it works.
Okay, you know what?
Oh, it's blue. Okay, well
And it's blue.
that's interesting. I mean, it's interesting.
Yeah. Let's just
I
try
don't know why
running it
it's
again from
blue.
the start. Maybe it was initialized in a weird state.
Yeah. Okay. Well, it's
All
not
right.
blue.
That's well, it also has no
So
heat.
yeah, but it's not blue. So victory #1 for
Yeah.
that. Oh, that's
Oh, now
interesting.
it's blue.
Up, up, up. But it only goes to the east. Oh, no, that goes west.
Hold
Aha,
on. Is
right,
that
because the flow direction.
yeah? But is that the opposite direction of flow though? So like, on a big mound or whatever. Oh wait, I guess so you're not doing it north south.
Nope.
See, but it's going the opposite direction of flow. Restart.
Okay.
So restart and then put some heat down in the very middle, like at the bottom. Yeah, and then now make a pile off to one side, and I bet it's gonna flow toward it. What in the?
Broke it.
Okay. Yeah, make some more heat there where it was before. See, I think it's flowing the wrong direction.
Okay. And so I'm just going to use water this time over here. Bunch of water. Oh, okay. Yep. All right.
Okay.
Well,
So two
some
things.
negatives in
It's
there.
going the wrong way and
Yeah.
it's blue.
And it's going there super fast.
Yeah.
Okay. So this
I
was
wonder if this
correct.
zero protection is screwing us up.
-1. Huh. The western's eastern flow. So that's inflow. Outflow. Negative inflow is outflow.
You'd think.
You think. So this should be the flow outflow.
Yeah. And it should always be a positive value in these cases.
Mm-hmm. And this is the same because if it's actually flowing in,
Mm-hmm. Then that's negative. And then the pixel's temperature is positive. Or 0.
positive or 0, which is then this is positive and heat flow is positive.
Which means you always subtract heat. And you should never be able to subtract more heat than you have. Because the heat flow out is
Why can you not subtract more than you have?
because the water W, like the heat flow out of each type has to be less than the amount of that type that you have. And so since the initial heat that you compute is the sum of all of those is greater than or equal to the sum of all of the outflows, then
Mm-hmm.
this value can never be negative. As assuming those other things are true.
Okay.
I mean, you could try maxing this first term with 0, and if that changes something, then we have other problems.
Yep. Let's find out. Yeet. Huh.
Huh, indeed.
Yeet.
Hmm.
Heat is here. Come get it. Nope. All right.
Goodbye.
uh,
What does
so
that
this
mean?
is always negative?
That means it's, yeah. How is your initial heat calculated again?
Wait,
What?
I changed the direction of stuff here to west. Is that
Well, because this was an inflow versus an outflow, right? That's why you
Whoa,
changed that?
so this is now backwards
Wait, you want the eastern, wait.
because this needs to be the eastern, yeah, all of this.
All of that's backward. It's all
Ah!
backward. Okay, so,
All right, let's work with east,
okay. We're just gonna work with,
with north and east.
all right. And then how does
Okay,
that
so
make our life easier over here?
it doesn't. This is now backwards again, but at least it'll be
How is it
consistent.
backwards both ways?
It's backwards both ways. So the flow out east is the eastern flow of this cell
Okay,
times some stuff.
yes.
Flow out east times this cell. I don't know. Well, because so I did this earlier, and wait, this pixels that just straight up.
Okay,
Sorry, max 0.
well, this will always be positive.
Or sorry, min 0.
What?
What? Will it always be positive?
It should. Yeah.
These could be negative.
Well, right, but then hold on. If the flow out east term ends up being negative, then it takes
Yeah.
it's minus the min of that negative value in 0, which
But
would
this
make
is
it
flow out
positive.
east, not heat
Oh,
flow out
shoot.
east.
You're right. You're right.
Yeah. So this should give us blue, the eastern flow, which is blue.
Mhm,
Why is it
that's
blue?
correct.
All right, because these are big numbers. That could be
Are
greater
they
than 1.
are they Oh, the flow is greater than 1?
Yeah, max.
Wait, how can the flow be greater than 1? You're storing all these values in.
Because green is 1, and this is 1, and that is 1, and that is 1.
Oh, right. Okay, got it. Yep.
So this should give something more sensible, because it's maxed at 1. Oh,
Or just nothing.
or just not. Oh, max of that will always be 1.
Wait, isn't it negative? So it's
Ta-da, whee!
all right.
So eastern flow is blue,
Cool.
I think.
Yeah.
Oh, you know what? You could do a cool rampy ramp. Check it out. Oh, yes. Water's a little bit dark, but lava, eastern flow, blue, western flow, not blue,
Yeah.
blended. All
That
right.
looks cool. Okay.
Um, so this really is a
That really is
really,
the eastern flow.
yeah. I had that messed up earlier. I don't know why this works now. So this is some flow
Hmm.
going east.
What if we checked that by dividing it by your current heat and setting the R value to that?
Dividing by the current heat.
Right. Because it should always be, right, because it should always be less than 1.
The heat flow out, which is that, should be less than the old value. Yeah, because this has to be less than the amount flowed has to be less than the amount that you have, at
Hmm.
least
At least we would hope.
maintaining this universe's laws of physics. Everything is blue. Okay. Why is everything blue?
Oh, if there's no heat there, then so maybe add the plus small.
Plus small.
Not bad.
Blue
Really
is
wish
now
0
on.
over 0 gave you 0. That would just make
Yeah,
so many things better.
blue is becoming less and less good color to me. So
Well, so there's no heat in any of these, so you got to add some heat
ah
for it to.
right. Heat, heat, wait, heat,
Well, heat's not flowing, so you can't see it.
truth. Here it's flowing, I guess.
Okay.
Water, heat, question mark?
So I mean, no, this is right because it's only so
Oh, right, it's not
heat's not
actually
the heat's not
moving.
actually moving, but it is showing you that it's going to try to flow east.
Yes, these are indicators. Uh-huh.
So now if you like make a whole bunch of water on the left-hand side of that box, then they should all light up.
Why is it moving though?
Well, because more and more of the flow is going to the east. So I think this is right. So this looks right so far. And they don't freak out and go blue, so that means that the heat flowing is less than your current heat.
Okay,
So
that's good.
good sanity check.
Uh-huh.
Okay, so what were you gonna do next?
I don't remember.
uh, let's see. Do we get the orders correct on these? Like for the heat flow in the alternate direction?
Mm,
Or the counterflow, I guess.
is the western east flow
Yeah,
negative?
the western's east flow. Yeah.
Yeah. And then from here, it should be the same calculation as this one, because this is
Oh,
outflow.
right, because you computed outflow. Western's east flow. Yeah, that seems right.
Yeah. Yeah, which is just me doing this again. So this should always be greater than greater than 0,
Yeah, but it's gonna be
and
at
it's
less
going
than
to be huge.
5. or less than 4, right? So you can just divide by 4 and it will always be in range.
4, 4. Wait,
Because
4.
all our capacities are 1, and it's only the sum of 4.
Plus this pixels.
Well, it's times that, which is always less than 1.
Oh, multiply. Yep. Good call.
Cool. So theoretically, what should we see here?
No blue. No matter where we put the heat.
Ah!
Blue. Why is it all blue?
Okay, so well, that's all right. Let's figure out why this is blue because this is obviously so heat flow out west and heat flow out east. It happened as soon as you added heat flow out west.
Well, let's just see what heat flow out west is.
Yeah.
Divided by heat. Or divided by
The heat plus small.
4.
Oh wait, no? Okay, yeah. Yeah, just divide by 4. This should be something. Should be something reasonable. Whatever it is, it should not be blue.
I mean, it's not blue.
It's also not yellow.
Yeah.
Where is the okay, so stupid question, but where is the heat flow or that pixel being sampled? Like for the western cell.
This western cell is
So
being
for
sampled
what
from
like water W, where's water W? It's IUV minus fixed 2 texel width. Dang. I mean,
Yeah, that would've
there's
been
nothing
great.
wrong with that. I know, they'd be like, oh yeah, this is just the wrong direction. No.
Hooray! And it is the water, steam, lava, dirt, height textures, the main textures.
So heat flow out east should just be the mirror of heat flow out west, right? Like for two adjacent cells. So theoretically, whatever
Has to
picture we
be.
get for, so we should do maybe like
Well,
heat.
let's just try that. See what happens.
Yeah. So if we get blue for this as well, then I guess it's not as bad as we thought. But
What we get? You get nothing.
huh. Okay, because it's being overdrawn by white, I guess.
No.
What is happening? Okay, so it's at least working. Is this thing on?
Testing.
Bueller.
Is heat so low that we can't see it? No, because these are all ones.
Right. Yeah, so if there's any amount of stuff there at all, we should be able to see it.
But why did this work?
Maybe, I mean, maybe heat is really low. Wait, oh, you didn't
It's all
do
blue.
you didn't do plus small.
I did not do plus small.
So now it should be white until you add some heat.
Yeah.
Neat. Okay, so now just replace that with heat flow out west.
Yeah.
This better not be the same.
Should not turn blue.
No, I want it to turn blue because I want it to be
You
the
want it to
problem.
turn blue. Okay. Well,
No.
it's oh, there you go. I don't know why it
It's
does that jump.
sometimes, yeah, that's a weird little pattern there. It's like it sometimes goes west, but mostly doesn't. This is correct. I mean, well, hold on, where'd that blue come from?
I
There's
don't know. Bunch of negatives.
how does
See
this
something wrong with
happen?
this equation?
Yeah, no, this should always be greater than 0. I don't see a way that it can't be. Because
so
the
if
top one is always greater than 0, the bottom one is always less than 0, and you subtract the
if
bottom one from the top one.
if this is negative,
Yeah.
oh wait, no, but this can either be positive or negative.
Right, it doesn't matter
Yeah, it doesn't
because
matter.
of the next piece.
Wait, but then this is
Is heat ever negative?
heat's never negative. It can't be negative. The lowest temperature is absolute zero, which is zero heat divided by some material.
Okay, so how sure are you
Not sure about
that
this. I don't
that
know.
that not that the flow is not taking more from a cell than the cell has?
Uh, Pretty sure because it's max. There's the minimum with this pixel's amount every time. Right.
Is flow inflow?
Here flows inflow,
Inflow.
I think.
Okay.
East minus this, yeah, assuming that the other cell has more height. This is positive, and the maximum of that, and that is greater than zero, being in, yes.
So hold on. Let me read this because this is new for me. So height pixel north, the amount that you have is dot r the amounts?
Yeah, DARs, this is all DARs.
Mm-hmm.
North and south have the extra flow gradient,
Okay.
which does the up-down motion.
Right. So the flow north is the minimum of.
We can also just get rid of north and south.
No, it's okay. This is just a really complicated like little expression here.
Mm-hmm.
So height pixel is the height
Yes, is the total height of all elements in that
of
cell.
all elements in the cell. Okay. So right, so flow gradient, the total height, and then you say you take the min of, so whichever one's lower out of the difference between the north pixel and yourself plus the flow gradient and the amount that you have in yourself, or no, the amount in the north.
Mm-hmm. Because this is assuming that the north has more.
Hmm. Yeah, if the north has more, then you take the max of that in zero, and you. But hold on, isn't this pixel north dot r? Isn't that's the sum of all in the north?
Yes,
But doesn't the north also flow east and west, and therefore you can never you can't take that much?
that's why you have the flow divisor.
Oh, right. Okay. So
So
in the
yes,
flow
you can take
divisor,
up to 1 from that, and then it's divided by 5 and a bit.
yeah. So it's divided by 5 and a little bit. So you'd never be able to, basically all of it will never flow out.
Yes.
Okay. But it will get progressively smaller and smaller and smaller until it eventually reaches zero.
Yes.
Okay. So that seems right to me. Which means then when we actually take the flows, we assign them into G and B. A is the amount that we had before. R is updated to have the flows, the outflow values computed,
Inflows.
or sorry, inflow values, right, inflow values computed. Wait, hold on. Those are inflows.
Mm-hmm.
G is an inflow.
You know what?
So we go back over to the other one where we're using it as an outflow.
You were right before, like half an hour ago, where you were saying that I should take 1 minus this. And I was
Hmm.
like, oh, no, I could just take the western flow. But it's not. It
We actually
has to,
need
it has to be 1 minus the
Well,
eastern flow
o-
because this is the outflow.
is it 1 minus?
Oh god, I don't even know anymore.
You know, we could just switch the logic on the other side
To all outflows?
to all
Or sorry,
to
inflows.
all inflows. I feel like keeping that consistent might, because sometimes when you do okay, so my
Yeah.
reasoning here is sometimes when you do a 1 minus,
Yeah.
the floating point calculations get screwed up, and especially when you're
Oh, okay.
iterating them a whole bunch, you might end up with a weird
Hmm.
situation. So okay,
All
so
right.
old heat's correct.
So it needs to be inward,
Right. So
flow
this is
in east. Boom, done. That's how it works,
done.
right?
Okay, so now you need to switch the, so these are all, hold on, flow in from the east. Yeah, that's correct. So, however, you need to, in the heat flow in from the east, you have to switch the temperatures because that one has to be the temperature from the eastern cell, and
Yes.
the other one
And
has to
this,
be my temperature,
yes. And this is flow in from the west.
which is the negative of the western cells in from the east. Yeah, that's correct.
Uh,
Wait, hold on. In from the east, in from the west is, yeah, it's the negative of the western cells in from the east. That's still correct.
Negative western cells in from east is
Hmm.
this. Wait,
In
so
from west.
western cells in from east is this cells out from west. Negative that is this cells
Wait, wait,
in
wait, wait.
from west.
What?
So the western cell
Oh, is
takes
this
in
cells?
from the east
Oh, yeah, yeah.
is this
Okay, you
cells
did it in two
out from
steps.
west.
You did it in two steps. Okay, yeah, got it.
So negative that.
Hmm.
So the western cells in from the east
Yeah.
is that.
Yes.
And it's out from west, or in from west, so we take negative that.
Right. Okay.
Oh, and then
And then this one, you got to do
in
the
from
temperature update the
west
same.
is the west, and if that's negative, out from west, we want that.
Right.
But this is, yeah, because then this will be a
Because it,
value that gets negative, and then,
right.
well, what does that do?
Does blue? I see blue.
Wait, it
Okay.
was blue. It was blue before.
Okay.
That's something. I don't know
Something
why
could,
that happens.
huh. Wait. Hold on. Psh.
So if it starts to flow east, this happens.
Yeah. So let's go look. Yeah, if it starts to flow east, it just goes east like crazy.
Hmm.
So that's heat flow in west. Is our assumption about being able to just take the negative of the flow from the west incorrect?
I hope not, because I don't have
Right, you
5
don't.
channels.
Yeah.
I mean, they have to equal.
Yeah, they do. I think we're in a pickle. I don't know what to test.
Yeah.
Maybe flow in from west? We could just check the
Flow
flow
in
again.
west.
Yeah, so flow in from west, and that value just divided by 4, I guess.
It's going to be super small.
Is it?
Yeah, because remember, this is cycling 2,000 times a frame.
Right. Okay, so I don't know, maybe times 5 instead of divide by 4. So because we're looking at, and what this should do is this should say this is flowing in from the west. So if it's flowing to the east, then we should get a color.
Sounds right to me. Nope.
That's flowing to the west. So that's just wrong then. Wait, actually, can you clamp that with 0 as well? Like max with 0?
Yeah.
Because I'm wondering if we're only getting a color because it's overflowing or something. There you go.
Yeah, okay, there it is on the east.
Cool. Okay, so that is correct. It is flowing east. So
And this should show the other direction.
right, which it
So that
does.
is now, yeah, it's that way.
Yeah.
So in from the east, yes.
Okay, so let's do something dumb,
Mm-hmm.
which is we just take how am I gonna do or how should we do this? It's like heat minus instead of rescaling everything by heat capacities, what I'm thinking
Mm-hmm.
is like there should be some way that we can just move the heat with the flow, and that's it.
Move the heat with the flow.
Right. So take like heat flow in from the east as a how do we conserve this? Heat flow in from the east is flow in east times all that stuff times the other pixel's temperature. Well, I mean, I guess this is just. I feel like this should work.
This is
I
kind of
don't,
where I got to,
I don't
where
get
I'm
it.
like,
This should just work. What if? Okay,
well,
so
let's try it.
I mean, I guess we haven't just done this in a while.
Yeah, see what happens.
Yeah, let's see how much blue we
Maybe
get.
it does work.
And you know what's gonna happen? We're either about to get really tilted.
Um, I mean, it goes away.
It,
Did
I mean, we didn't get blue. Wait, okay, we're maxing that with 0, which that shouldn't
we
matter
shouldn't do
because
it?
it should never be negative anyway.
Yeah. Heat minus that, minus that.
Yeah.
Wait, wait, wait,
Hmm.
wait, wait. Those are inflows now.
Those are inflows.
Oh, yeah, that looks right.
Okay, I think there's one other piece. I think there's one other piece. Uh,
Okay.
okay, so what we should do is instead of adding small, we should max it with the small value. So it's divide by the max of that and the small value,
Yes.
because that way we're not adding it in situations that don't call for it.
True.
Okay, maybe that makes it then, because it's spreading into areas where there's no flow, I think.
Well,
I mean,
it's just a very, very, very small amount.
is there a tiny amount of flow out there?
Oh yeah, it goes crazy. Like, but they're very, very, very small
Oh,
amounts. I
wait, so is this thing working?
think so. But it's
Huh. Okay, well, I mean, there's no north-south flow, so that's correct.
but it's massive. Like
Yeah, why is it conducting
it's
just,
solid yellow.
yeah, it's conducting all the heat.
Are we just working with values that are way too small?
How do you mean? Well, okay, hold on. So the heat,
Like, should I
that
just
might
multiply
be,
these to make them big?
well, hold on, no, hold on. Yeah, maybe. We might be, you know what? I bet you're right. I bet you were working with values that are so close to the minimum threshold of floats that it's actually making it, like, it's actually doing rounding problems. Because you have a
That's
very
what.
small amount of heat and a very, very small amount of water or of material.
Yeah.
So you end up dividing by very small amounts, and maybe you can make small bigger here. Maybe you can make the threshold bigger, and then because then you burn off. I mean, you burn off heat into the world, but
Hmm.
that's effectively what that does.
Conservation. All right. I want to
Makes
look at the world shader again. This is plus heat, which
Yeah.
is the yeah.
Hold on, which is a power?
Yeah, it's absolutely power.
Okay.
Um, I mean,
So the heat textures.
we can take that out.
Oh well. Oh, I mean, you're. Oh, say what?
That should just make it dimmer
Hmm.
and linear.
Oh, right, rather than exponential. But it's fully saturated each time.
Yes. Which is confusing me
Yeah, why is it getting fully saturated? So
because that shouldn't be able to fully saturate it.
oh, yeah, you're right. There's no way that that should work. Wait, hold
Unless
on.
this is
Your
also
RG,
super.
your average. So hey, broski, your
Oh,
average
god
needs to
damn
have.
it. Who needs parentheses?
Okay, let's see what's happening here. You know, that might have made debugging a little easier in the past, but
That's why everything was blue!
that's why everything was blue.
God damn
What?
it. I don't even know.
Okay, I still don't know how that's happening, but
Uh,
because there's
so
no way.
it's mega yellow, which means heat is 1 just all the time.
Yeah, but it can't be, right? Because
Uh, maybe?
there's no way. I mean, you divided it by 10 and the max value is 1, unless these textures can actually store full floating point numbers. Dude,
Uh,
I wonder if, so how did you declare these textures?
so they're floating point numbers. They're 32-bit floating point. So I guess they can store numbers greater
They
than
could
1?
store numbers greater than 1.
Uh, okay.
So that's got to be what's happening. Now the question is,
Well,
why is the number greater than 1?
I mean, that makes my other lives a lot easier. Like the height shader can just not be divided by num element.
I mean, let's not do this conversion now, but yeah, that's something that, I mean, we should,
Yeah, that's something to keep in mind.
it's something to keep in mind. We could test that too, because I'm not like fully confident that this is true, but I know that there are like compute scripts that can use that they use the full, you know, floating point values, but I could have sworn you always had to normalize it when you were actually passing it back down into a shader.
I mean,
We're learning on the edge here.
yeah.
You know, just like debug println or something like, hey, what's going on?
I I could,
Wait,
but
oh, this is never mind. That's
I want to turn
a
the world
shader.
red.
Yeah, turn the world red.
So that's dirt. That's lava. Here's some heat. Hmm. Let's turn the heat shader back to realsies.
That's not assigning anything. You got
World red.
it. Okay.
So this is greater than 1.
Yeah, like definitively.
Like absolutely massively greater than 1. And I don't know why.
Okay. Here's a guess.
Uh-huh.
Your new heat capacity is lower than your old heat capacity, right?
That can't change. Capacity is always defined by
No,
that.
no. But your so your total heat capacity here is being multiplied by the new values of each of these things that is present.
True.
So, however, the amount of heat that's flowing out, so temperature should stay constant, right?
Yes.
If
Yes.
you're flowing things, temperature should stay constant. So let's look at what we have on the two sides here. We have where's I need to type. I need to type. We have I'm not gonna type there. I'll type up here. It is I'm just gonna bake everything down. Just use water. Okay.
Hmm.
So we
Yeah.
have water old times cap water times temp old, right?
Yeah.
That's the old heat.
Yeah.
And then we have why does it do it that way? That is just the worst. And then here we have temp new equals heat old minus heat out.
Which is plus heat in.
Oh, I'm not gonna be able to edit this. Lame.
Uh-oh.
But then, so I just ignored how much this sucks.
Uh-huh.
And then over water
The
old.
water new.
Right, hold on, it's water, no, old minus water out, right? Times cap
Uh,
water. This follows, right? So because then,
water old minus water out. Yes, in
okay,
total, all directions.
right, total all directions. Doing all directions here. I'm just trying to,
Mm-hmm.
because this logic should all apply. So
Yep.
heat out equals water out times cap water, right?
Yes.
Okay. So now what we're saying is,
Aha, no, sorry. Temperature. Temperature of the water times cap water times water out.
hold on, where?
So temp old.
Oh, right. Times temp old. Okay. But now we need to say, so this is what's supposed to hold is that temp old equals temp new.
Yes.
So if this is true, then water old times, oop, hold on. I'm gonna move down here, I guess. Water old times cap water times temp, wait, over heat. Hold on, I gotta do this the other way. Come on, let me backspace. So it's heat old over water old times cap water equals temp old. So I rearranged this equation up top here.
Mm-hmm.
And that that equals heat old minus water out times cap water times temp old over water old minus water out times cap water. Okay, and these two things are supposed to balance. So I th
Huh.
wait, hold on. But there's no way this can balance. So I think there's something about how we're doing this flow that is just wrong. Do you see why? Because this is temp old, and temp old is supposed to be the same as temp new.
Mm-hmm.
But temp old is involved in this right here, which means that necessarily the rest of this, so if you're multiplying by temp old in here, like the rest of this is going to have to basically cancel out and end up just multiplying by 1. But you kind of can't because there's this heat old parameter in here. Wait, hold on. Heat
Yeah.
old is this thing. Heat old is this. Water old cap water. Heat old. No, hold on. Heat old goes here, which is water old cap water temp old. So you can factor out temp old, which means that, okay, man, I wish I hadn't drawn over that because so you can factor temp old out of that equation and say temp old times water old times cap water minus water out times cap water over water old. Okay, so actually, no, this is right. Because so cap water gets factored out, water old minus water out, water old minus water out, cap water. So then this becomes 1.
Mm-hmm.
And then, okay, so then we're good. All right, fine. Erase everything I just wrote. Because
Dang
The
it, the
math,
math works.
well, the math, so okay, but the math works with one element. I don't know if the math works with multiple elements.
I mean, the rest of them are zeros if you just have one element.
And that's how you've been testing it, is just with one.
Yeah. So we have steam, we have heat.
And it's flowing in the right direction now, but it's still getting saturated.
Yes. It's getting mega saturated.
And so it's becoming, can you clear the screen?
Oh yeah, sorry.
Thanks. So it's becoming saturated, and that you're detecting that by showing red.
Yes. So in the world shader, if the heat is greater than 1, it just turns it
Yeah,
red.
it just returns
Otherwise,
red.
it would turn it. It would.
It would, yeah, do the black and white thing.
Yeah.
So the heat is power of the sample of just the red channel by 1.
Or that.
Well, I mean, okay, that rescales it for sure.
Or we could just do that.
Yeah, let's
for
just
now.
let's just sample it and see. Okay, so run that and let's see if see what it does.
Steam, heat.
It even got yellow in a couple of pixels there.
Did he? Oh
Yeah, I
yeah.
saw it on the edge. Yeah,
Blended.
so a couple of them are correct. Wait,
So that's not flowing
when
because
it's
that's
not,
dirt.
yeah, when it's not flowing, it gives you correct heat values.
Uh,
Okay, dumb question. When it flows in from multiple directions,
yeah.
can your heat exceed some capacity?
Hmm.
So because as soon as you flow once, then the next flow will be from both places at the same time. Right? Isn't that right?
Does it matter?
I mean, shouldn't, but maybe.
Because you have east and west accounted for.
When are temperatures updated? Wait, temperatures are updated here.
This. Yeah. None of the actual flowing is flowing.
Okay, so heat flow in east. So what if we took the min of the temperature and 1 in the calculating the heat flow? So like this pixel e dot r. So sorry, not here. Up where you're calculating heat flow in from the east.
Heat flow in east.
Yeah. So this pixel east dot r, take the min of that value and 1, because maybe we're getting extra flow from a direction.
Okay.
And then same thing for this pixel, like this pixel's temperature.
Ah, yeah. Okay. Hmm.
So I mean, you can still potentially get too much here. Well, you still definitely get too much. Man, how is this happening? Well, okay, hold on. Heat flow in. No, you still only have one thing. You're still just doing steam, so you should never get more than 1 because we set the capacities. We did set the capacities to 1, right? We're not up in some.
Maybe. Maybe the capacities are 1,000.
Oh my God.
But it's divided by. But it's divided by it at the end, right? The intuition. Yep, that doesn't make a difference.
Okay. All right. Well, I was
Okay.
going to be very sad if that was what actually happened. Okay.
Yeah. I mean,
So
we could simplify this if we want to and take
what?
out a whole bunch of the
No, no, no. I
stuff.
mean, we could, but we know that we're only using one element, so it's okay. Okay. So we're assuming that the dot A is the right thing to do, like to use the last value and then the next value. What if we just did dot A again at the end instead of dot R?
Um, because we're adding heat to something.
We're adding heat to a location that doesn't have anything in it. I don't
And then
know.
we have positive heat and no value.
But
Did that work? No, because otherwise the yellow would be moved.
well, no, it only moves when there's something on top of it. So you got to put some heat up at the top there.
Well, but this should be flowing with the. As soon as
Not
the steam hits this,
well, it should be flowing a little bit, but not vertically.
right? Because it doesn't flow.
Yeah.
Water, heat.
So
It's kind of flowing
yeah, it is flowing.
a little bit.
I mean, but it's
It's also turning red.
it looks like it's not getting. It looks like the heat isn't leaving, like that it isn't ever leaving a pixel. Does that seem right? Wait, 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 wait.
Hmm.
That's exactly what's happening.
What do you mean?
Heat flow in is never negative.
Wait, is this just like this?
Hold on. Flow in west because you need this is breaking my brain right now.
Uh,
So because okay, so you still want when the heat flows in from somewhere else,
mhm.
then
Oh, so we have to have a double switch.
you want to be using its heat. But
Yeah,
you need the value to still be negative.
yeah.
So okay, so what you do? So okay, here's the trick. Here's the trick. Keep it.
Uh-huh.
So go back up to heat flow in east, and make that whole expression. Put it in in parentheses,
Hmm.
and then before it, do times or so do sine sign of flow in east times that. So sine will just be -1 or 1, depending on if it's positive or negative.
Okay.
And then you need parentheses on the bottom one as well.
Yes.
Okay, and then we can go down to the bottom and flip the A's back to R's, I guess. Well, actually, let's just do this one stage at a time. We'll need to flip the A's back to R's.
So, okay. Water, heat, flow, my
No,
pretties.
flip the A's back to R's. I think that's the final piece.
Flow, my okay.
Oh no! Ah, I was so sure about that.
Er,
Man,
Yar, me hearties.
because okay, so this is something though, right?
Yeah,
Because
yeah. No, it's true.
it was never going negative, and it should have. So flow in from the west. So you do want to add that. That is positive in the correct direction, right? Because if it's
Because
flowing
this
in,
plus whatever flowed in will
hmm
give you this amount. But the flow in from the east is flow in from the east, which you take from the shader here, which is green,
hmm
which is flow east, which is
yeah, which is
assuming
as
the other cell is bigger, is positive.
hmm
Positive to zero. This positive number in.
yeah,
Yes, check.
and it is. And flow, and if you just to be sure, that does work over there, right? Where if you're flowing the other direction, like if you flow out, then it is negative,
That minus, so
right?
0 minus the
Okay,
max of
that is
flowing to the east.
okay. So if you flow out, it is negative.
Yeah,
Then back in the world shader, if you,
or
or
in
sorry,
heat
in the
shader.
heat shader.
Yeah.
So if you're flowing in from the east, then that's the flow times the capacities, which those are all we set those all back to 1.
Mm-hmm.
Those amounts times the pixel from, so flow in from the east.
Heat.
If in from the east is positive, we take the eastern pixel's temperature, and otherwise, if it's so flowing from the east is negative, then that value is going to be negative, which we take our temperature, because that's the amount that we're going to lose, and then we say we take the sine of it, because if we are negative, if flow in from the east is negative, then we need to flow out.
Wait, but this would be 0.
Yeah,
And this
if it's
is
negative.
minus that, so it already is negative.
Wait. Minus the
Or wait,
min.
we could just do that
Yeah,
and get rid of
cred.
the sign.
Yeah, no, wait. Plus the min of, yes. Yeah, you're right, we could.
Eh? Don't know how
It
that
should
would
be
change.
identical. It should be identical.
Should be identical.
Yeah,
Identical test? Yes, identical.
and
Okay.
identical result. Okay, well, so you are correct. Getting the sign, so we can get rid of the sign call. But why is it turning red? Like, why are we getting values greater than 1? This is just driving me up a wall.
Mhm. Well, so yeah, so it's not. I think there's something about it's not leaving.
But
What
okay,
if
so
we just
this,
do one direction? What if we just do one
sure,
direction?
let's just do one direction. That sounds good. So,
So we have
yeah,
heat flow in east.
good idea. This is a really good idea. So
So
heat should still flow.
yeah, plus. So but this will infinitely increase.
Hmm.
But it should delete from one.
Well, it should, hold on. Heat
No,
flow
it
in
shouldn't.
from the east. I don't know. Run it and see what happens.
Right? Right. We've done
Remember, this value can be negative.
I don't remember. In any case, it's too small to see. What does that do? That should always go to the east and should cap out. Or west.
Well, if it's going to the east, then it's negative, so you're not going to see it.
Yeah. Oh wait, because in west can be, or in east can be negative.
Well, in from the east means it's flowing to the west, so that's positive. So that's why it's on the correct side, right? Because if you're coming in from the east, then you're a positive value, which means that it's going to be correct here.
But then if it's negative,
And if it's negative, you're not going to see it.
well, if you start with some value and you add a
Oh,
negative,
you're right. If you start with some value, then yeah, it should be.
so I just put up 2 walls of heat and slap some water in between. These should go away.
Right, because there should be heat taken from them.
Yeah, 2 that way.
So that's the piece that's not working then. That has to be it. Wait.
Yeah.
Oh, wait. You know what it is?
No?
These aren't floating point values. The dot G is never negative. You're never getting the negative flow. So what you need to do is you need to rescale this to the range 0 to 1,
Of course.
and then scale it back in the other shader.
Of course.
That's why. So
Okay.
hold on, hold on.
But
Scale.
you know what?
What's up?
These are floating point numbers.
Well,
Can they be
yeah.
negative?
So yes, they can be. So yes, they can be negative. But actually, I don't think that these are behaving how we think that they are.
Okay.
Like I think they. Well, so the answer is I have no idea. But you know what? Nothing else has worked so far.
It's true.
So,
Uh, so
but I'm
now they're
pretty sure about this one. So
uh,
all of these you need to scale. You need to do.
from
Yeah, so you got to parenthesize all of those. I'm looking up.
yeah.
Hold on. There's a scale command HLSL. I'm looking for an intrinsic function that just turns it back into a different range.
Mm-hmm. Otherwise, I have to do that.
Yeah, otherwise you got to do that every single time. I mean, you may as well get started doing it until in case I find it.
Or wait, is my math correct? Oh
In
god.
case I can't find it. Let's see. I mean, there's lerp, but
Divided by 2? Why can't I do basic math? If I have a value, multiply it by a half, add it to a half. Then I want the value back. First I have to subtract a half. Then I have to multiply it by 2. Yes, okay.
mhm.
Basic math. Basic math. That. This.
Yeah, we can work on optimizing this another time.
Mm-hmm. Boop, 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 boop. Does that work? Let's find out.
Did you do it for all of them already? That was fast. What in
Boop.
the what?
I don't know. I don't know.
Hold
Did
on.
I fail my basic math again? So,
You didn't subtract, so yeah, you got to do it in the. So it's not. Wait, hold on. The water dot. So this is going to be. It's not two times that. Hold on, two times that minus 0.5. No, it's minus 0.5 times 2. So, or it's 1. Wait,
what?
hold on. Negative 1, not negative 0.5.
Negative 1
Yeah,
plus 2 times
because 2 times
that.
0.5 is going to be 1, and that's and 0. So 0 is now in the center of the
Right.
range.
Right,
Yeah,
because I have to multiply everything by 2.
right. Got to
That's
multiply
not
everything
my
by 2.
basic math. Alright.
Flow in from the east. There we go.
Distribute.
Go gadget
So,
numbers.
team, heat. Well, that's
Now it's
good. That's good.
that's what that should
Those
be
should
doing.
be increasing. Those should be going away. All right. Copy paste.
Nailed it.
That west.
Yes.
These all need to be like that.
So they're
This
rescaled,
needs
the
to
whole
be
thing.
that.
Yep.
Copy that comment. Put it there. Is this the same? This is the same. Okay.
Yeah.
And then that's gone.
I've got like everything crossed.
Oh no!
You gotta be kidding
What
me.
did I do? What did I do?
Hold on. Flow in from the west is the water west green component. So rescaled, mapped to the correct range. And then if you are flowing from the west, the heat flow is flowing in from the west. It's the western's heat plus the min of, if it's negative.
You know what? First,
What?
I'm just gonna try
So, okay,
that.
wait, float in east? That was those.
Oh no.
So, so what I was gonna say, so why, when we were looking at just the flow in from the east, why were they turning red? That's what I'm like. Why were they getting?
because because it was never subtracting.
Why was it never subtracting?
Because there, so we have a cell,
Mm-hmm.
and we're flowing in from the east, and it's me plus in east. And if the flow is in this direction,
Oh, I see.
it just keeps
Right.
going up.
Okay.
And
Got it.
and the
Got it. Got it.
cells
Got it.
over here
Yeah, they
always
were
kept going down because east was negative.
right. Okay. Thank you. Just want to make sure we don't skip something.
Yeah, so this should do the same thing,
Mm-hmm.
but in reverse because west is
Yeah.
alive and east is set
Right.
to zero.
Okay. Yep. Yep. I'm with you.
Everything is red. Okay, what did I do?
I don't know. Reset it. Just try restarting it.
I thought I just did.
Oh, did you?
No, didn't. Okay. Yep. Heat.
Eh? So
No, something's wrong.
flow from the west is just not. It's just not there yet.
No, it's not happy. Um, hmm.
It looks like it's identical. So
Wait, this is inflow.
right. But we should be in the range negative
Right,
1 to 1 now.
because negative,
Yeah.
that should be outflow. Or wait,
No, that's inflow to the that's inflow to the western cell, which is coming from this cell.
from the east. This from the east, and this is all inflows. Yes?
Mm-hmm.
Okay. Read my comment. In from the east, this cell's out from the west. Negative that is this cell's in from the west. We want in from the west, just negative that. Just same as that. Okay.
Okay, dumb idea, but what if we computed flow out in the western direction rather than trying to make it in and then handle it that way?
Uh,
So you don't multiply
so
by negative 1
this
and you rename it to out west.
and that.
Mm-hmm. Then out west comes from this pixel. I mean, we're just reversing all the logic, but I don't know, this shouldn't do anything. So the other piece is where you assume the flow outgoing, like in this min here in the middle, in this piece.
Yeah. I think as well. Wait.
Okay.
So if this is negative, wait, so this is positive.
Mm-hmm.
Outgoing flow is the outgoing flow times this pixel. Yes.
It's
And
if it's negative, then that value is negative, and it gets its max is 0.
this get
Yep.
minned out to 0 because this is positive.
Yeah.
Now, we've checked this logic like 7 times.
I know. Yeah, I'm pretty confident that this is okay at this point.
Well,
But
let's see what
I mean, the
Unity
shader's
says.
telling us something different. Yeah. Shader's telling us no.
Unity says.
I feel like we're right on the edge because it works in one direction and doesn't work in the other direction. So what is...
All right.
Okay, stupid question again. Let's look at water W and or steam W and where that's coming from.
Yeah.
What's the Texel width? You've got to be kidding me. This is exactly, it's the exact right thing.
Why is it gotta be correct like that?
Why is it gotta, why you gotta do me like this?
So, just to double check,
Hmm.
the right going right it disappears, going
Yeah.
left it goes to infinity. All right,
Yeah.
cool. So double checked that really works.
Yeah,
And
that
it's
heat
just
flow in the
because
eastern
we have to-
direction, that just works.
Uh,
I feel like it's got to be staring us in the face. Like this is
Wait, what?
whatever the problem is here. It's
Oh, right, because heat west is 0 with heat east 0. So this is the western times some stuff. Heat west.
does anything else need to be rescaled? Is that the
Wait, do we even use heat west?
No, we
Use
don't use
any of
those
this?
heats. Mm-mm. No, we use heat. We don't use heat west.
Ah,
Because those are the total heat values for other cells, which we don't care about.
yeah. All right, simplify.
Okay.
These are correct. So we only use heat.
Hmm.
And heat is used there, and that's it. Okay.
So that's the same for both. Cool. The heat flow in from the east is the sum of those values times their capacities, which are all 1 right
Does this
now.
need to be negative?
You know what? Just make it negative. Let's see what happens. At this point,
We're reaching.
I don't have a
We're
good
just-
reason, so let's just see what happens here.
I have a feeling it needs to be negative.
I got this
Why does
intuition.
Why does it need to be negative?
Wait, that makes it.
It's the same thing. It's the same thing.
How is it? How is it that it's doing the same thing?
This does the same thing as this thing. If you make it negative.
How? How, though?
But if you make it positive,
Does the symmetry not hold? Is that the?
I don't know. It's just. Am I missing like a plus small somewhere?
No, it's got to be that this so that there's. Okay, let's do something else. So in your flow shader, set the just obliterate the flow north right now, and where it's a this pixel dot b equals flow n.
Uh,
Replace the dot b with the flow w, and then we're just gonna do the exact same thing, just using the data, because maybe our
Uh,
symmetry assumption doesn't hold.
so this is dot B's
Hmm.
because B's is the western flow.
Right, but now this is flow in from the west, so we
Flow
need
in.
to
Huh?
yeah we need to update all that. Sorry.
All good. All good. And this is plus.
And yeah, we need to reverse those again.
Here. So this is basically a copy paste except B's instead of G's.
Hmm.
That looks
And
good to
assuming the
me.
flow all is calculated properly, which we're pretty sure it is, then this
Yeah,
should
I
just
hope
work.
so. Yep, that works.
Okay, so the symmetry property doesn't hold. However, if you uncomment both of these, for the first time ever, we
For
just
one
get,
night only.
you know what? Now it just turns purple, and I don't know where purple's coming from.
Uh-oh.
Does
Now
it
the
just,
heat doesn't move.
how does it do that?
And it's always greater than 1? Question mark. I broke it. Ooh,
Oh my gosh.
I don't know.
I don't know either, man. I think we might be stumped.
Alright. Clean it. Wipe again.
We're so close. We're so close. I feel like we just need to get the east flow piece. Whatever logic is happening there is the correct logic. But
In this.
yeah, it's something about either how it's being summed or just another piece in here.
If our. So does this hold?
the west pixel's temperature.
Yeah. That should work because that's the previous temperature. This is our
Hmm.
previous temperature, and those are the previous flows.
Right. Yeah. So everything's being computed using previous values. Okay, maybe that's okay. So down in temperature is divided by heat capacities, or heat divided by capacities. Use dot A again.
YOLO.
YOLO. I don't know why. Let's just use dot A. Oh,
Right?
good. Well, now it's yellow and not flowing.
Yeah.
Pretty sure it's not flowing.
Yeah. It's that looks like not a flow to me, boss. Yeah. But at least it's yellow.
I mean, that's better. But why would the
So are these just always equal? Are they just equal and opposite?
well, how would that work? Because then nothing would ever move.
Right?
So, I mean, let's go look at the we can go look at the flow shader. Flow W, flow E.
Mm-hmm. Just calculate it on the west pixel, and
Hmm.
this is calculated on the east pixel.
Okay, silly question, but no, that okay, no, they have to flow east-west because otherwise you would never get it. Like you could pile up stuff on one side and it would just kind of stay there. My
Yeah.
question was going to be like, well, have we ever seen it flow east-west? And the answer is, well, duh.
Yes. That's what we did last time.
Yes.
Uh,
So
get rid of
let's
these
see.
bins.
I don't know.
Those are basically debug statements.
Yeah. So they shouldn't do anything, but
Mm-mm.
who knows, maybe.
We're reaching here.
Yeah. It's still greater than
Oh, you know what?
what?
Oh my God, do you see it?
That we're setting the flows to zero.
Yeah. Hey, you want to know how you don't get any flow? You just set them all to zero. I mean, that makes sense to me.
It's
It's too late. It's too late, man.
it's
Okay. And then we change these back to our. It's just reaching.
why isn't it flowing? I can't see it. I feel like I'm taking crazy pills.
So I'm taking crazy. But all right, now it's blue again. Why is it
Why
blue?
is it blue? Uh,
Is it because these need to be min with one? Because that would be sad.
no, it's no. No, those are debug statements. That was okay. I'd say
I,
we
yeah,
are
I
almost
feel like
there,
it's a little bit late.
but we can finish this up next time because if we're not even seeing the part where there's something it's like, hey, the thing that you want, yeah, you're setting it to zero. This is probably
Yeah.
this has probably been enough for one coding session.
Yes.
Okay, well we
Well,
are we are almost there though. I think probably next time. I mean, so feel free to work on this your own time, but next time I want to see some heat flowing and then we can get state changes working. That'll be pretty cool.
yeah, that'll be fantastic. Well, I had a great time.
Me
That was a
too.
good laugh.
This is
Yeah,
pretty exciting. This is fun to work on this with you, man.
yeah, it's a lot of fun. Thanks for
All right,
thanks for taking the time.
cool. Yeah, you too. All right, signing off. See y'all later.